So now moving on to our next speaker, which is Professor Mu TaiHua. Professor Mu is the Chief Scientist of Fruit and Vegetable Processing and Quality Control Innovation Team, and the Director of Fruit and Vegetable Processing and Preservation Research Center, Institute of Food Science and Technology, Chinese Academy of Agricultural Sciences, and is a specialist of modern sweet potato processing technology, research system of Ministry of Agriculture of People Republic of China, and the chief scientist of the National Key R&D program of the Ministry of Science and Technology of the PR China. Professor Mu is also the Vice President of China Starch Industry Association, President of Potato Branch of China Grain and Oil Society, President of Sweet Potato Starch Branch of China Industry Association, Vice President of National Potato Staple Food Industrialization Science and Technology Innovation Alliance, and the Judge of European Union Horizon 2020 project. Professor Mu is mainly engaged in the research and application of emerging processing and comprehensive utilization technology of root and tuber crops. So far, Professor Mu presides over or participates in more than 70 projects in National High-Tech Research and Development Program, National Key R&D Program of the Ministry of Science and Technology, the Horizon 2020 project of European Commission, National Scientific and Technological Support Project, Scientific and Technological Achievements Transformation for Ministry of Science and Technology, and Corporate Cost Cutting Project. He is the author of 53 CN patents, 7 national and agricultural industry standards, 230 peer-reviewed journal publications, and 35 book chapters. So he is presenting on the topic of research and development progress of potato staple food processing technology in China. Over to his presentation, please.
Hello, everyone. It's a great pleasure to make the presentation here. I will carry out my presentation by answering 3 questions. First, why we focused on potato? As you may know, China lacks natural agricultural resources. With the area of farmland and water resources per capita less than 1/4 of the world average. Potato can withstand barren conditions, drought, salty, and alkaline conditions, can be grown in cold climates and have a short growing season. And China is the leading producer of potato, with an annual production of more than 19 million tons in 2019. Previous study had confirmed that potato is rich in nutritional and functional components such as starch, protein, dairy fiber, polyphenol, and so on. Therefore, adjusting the planting structure and changing the crops to potato should be a good choice. However, at present, most of the potato in China are consumed fresh, and the production ratio is very low. Besides, the main processing products are starch and starch noodles. The few individual products and large nutrient loss greatly limit potato consumption in China. How to increase the proportion of potato in the daily food intake of residents in China? It is necessary to consider the Chinese consumption habits and develop a new type potato staple foods that are suitable for Chinese people. For example, steamed bread and noodles and so on. In 2030, the Ministry of Agriculture and Rural Affairs of China proposed the idea of a potato staple food strategy. So, what have we done in recent years to support the potato staple food strategy? Our research team focused on uncooked potato flour and high dairy food fiber potato flour processing technology, potato staple food processing and quality improvement technology, and the anti-aging and preservation technologies. So far, we have established the uncooked potato flour processing technology. This table showed that nutritional and functional components are effectively retained compared to cooked potato flour. We also established the high dairy fiber potato flour processing technology using potato residue generated from starch processing. This table showed that the dairy fiber content of the new type potato flour was significantly higher than that of cooked potato flour. Potato steamed bread has some disadvantages regarding taste, texture, and flavor compared to wheat steamed bread. Sourdough is a traditional status composite of many different microbes. In our library, 5 cans of traditional Chinese sourdough were taken as the research objects. The microbial diversity of different sourdough was analyzed. The best sourdough for potato steamed bread was selected. The dominant microbes of selected sourdough were isolated and compounded. The effects of different compounding radio on the quality characteristics of potato steamed bread were compared. The multi-strain compound starter was developed. The flavor quality of potato steamed bread fermented by compound starters was significantly better than that of steamed bread fermented by yeast. This table and the figure showed that with potato flour addition, the volume of steamed bread decreased significantly. There are 2 methods to improve the gas generating and gas holding properties of potato steamed bread. First, finding the suitable replacer for gluten from protein and food hydrochlorose. Second, improving the processing performance of potato starch, the main components in potato flour. Our laboratory found that agar wheat protein and HPMC were the best replacer for gluten. HHP treatment also could significantly improve the processing performance of potato starch. Based on the above research, we established the processing technology of the potato steamed bread with different potato flour content. The content of potato flour in steamed bread was increased from 30% to more than 80%. At present, potato staple food products has been successfully industrialized. This is the precision workshop of potato steam bread. In 2015 and 2016, potato steam bread containing 30% and 55% potato flour entered the market in Beijing. The third part of our research is anti-aging and preservation of potato staple food. This figure at the table showed that during the cooling and storage of steam bread, amylopectin recrystallized further reduced the water mobility and increased the hardness of steam bread. The compound enzyme formula used for anti-aging was optimized by studying the effects of different enzymes on steam bread hardness. The hardness of steam bread with compound enzyme decreased by 44% after storage for 48 hours. For the preservation technology, first, we analyzed the main microorganisms that caused the deterioration of steam bread. Then we optimized the spore germination agent formula, which could cause more than 98% of spore to germinate before heating. The germinated spore will be completely killed during steam or baking. In the cooling and package storage stage, UV treatment can effectively kill the mold on the surface of steam bread. Using this technology, the shelf life of steam bread at room temperature was extended from 2 days to 10 days. These are the potato staple food products sold in supermarkets in Beijing. In the next stage, we will continue to carry out research and development work regarding potato staple food. That's all. Thank you for your attention.
Thanks, Professor Mu, for showcasing some of the research that is imperative to achieve food security. I personally think that potatoes can play a huge role in achieving zero hunger. So we as food scientists, we have the responsibility to take steps in that direction. Finding better use of what we have or what we can grow more sustainably is the way to go. So our